Alrighty, buddy, welcome back to Two Dudes in a Train. I'm Roland, this is Ed over here. Right now he's designing a turnout for the reverse loop, integrating mechanical into electrical. So, but we'll get back to him in a moment, but right now we're going to talk about what a reverse loop actually is. Now, what a reverse loop is basically what a short is going to happen in a track if you have your polarities reversed. So, you're more or less going to have a reverse loop basically at a loop. You know, it's basically what it turns out. So if you got your main track coming in and you've got a turnout here, let's just mark these green for positive and red for negative. Okay.
Wait a minute now. Wait a minute now.
What's that?
No, let's do that over.
No?
Universally, red is positive, black is negative.
Oh, you're right there. Okay.
Alright, hold on. Let me explain this. Let me take over.
Oh, okay.
So, I'm going to set this back this way.
Okay.
Let's start this over. Okay, so, for what a reverse loop is we got our track that's going to come along this way. And then it's going to loop back and come back. Now the track has two rails. Now, here's the issue. As we wire it up, one is going to have a negative and the other is going to have a positive. Well, as we follow the positive along, you can see that right here it's a positive to a negative connected right here. And the same here, you'll have this route, which is negative, comes across and connects right here, and at this joint it's a positive to a negative. So this represents right here a direct short. Can't have that. What we need to do is be able to isolate this section like this. And then what we'll do is as the train comes along and makes it past this isolation joint, we'll have to have some way to flip the polarity, changing this track to negative and this track to positive. It'll come through here, and that way with the electrical switch it will break the connection here and keep this connection so that now it's correct feeding back into the line that it came off of. It's a little bit complicated. So we laid down the track, we actually insulated at the turnouts. Roland is going to come up with a way to push a button once it crosses this particular isolation block, change the polarity so that as the train comes along here it's going to feed right back in, the polarity will be correct, and the train will be able to continue running as if nothing ever happened.
That's the theory anyway.
That's the theory. It's a bit complicated.
Yeah.
And now they do sell ready-made gadgets. Digitrax has them specifically for this task. That makes this process very simple. You still have the isolation gaps. You just hook up the gadgets and they work. However, Roland isn't using that particular setup. He's going to set it up through Arduino, and he'll explain that a little bit more. But that's the very basic. So we want to avoid having a direct short where the track turns around and meets back up on itself.
Alrighty. Yeah, you explained that a hell of a lot better than I did. Alright, now let's hope I can explain Arduino and what my idea is as far as hooking this up. Now, I got a lot of my ideas through YouTube and through other subscribers like Tom Strange and stuff, I believe. Forgive me if you're watching this, I'll get it right next time. And a few other YouTube videos, and I have been playing with it before in the past with some of my robots that I built and whatnot. So I thought it'd be kind of fun trying to integrate it into the train layout here. Obviously it's an open source and it's, yeah, it could be a little finicky, but I think it could be fun in the long run. So, but right now, what Ed is designing is a manual throw switch that can actually operate a electronic micro switch. So you got the turnout here, and you have your turnout here. Okay, you have, you know, your crossovers there. What I want to do is incorporate a micro switch here for there, and then I run this over to the Arduino, and thus flipping a switch, because I want to try and keep everything as prototypical as possible for the layout and have a lot of manual throw switches. So I think this will be kind of fun in what I need to do, and I don't think any of the Digitracks or any other stuff would have allowed me to do this. Possible, I didn't check into it. Please forgive me, throw a comment if it does. So, wow, I got a little dust on there. Haven't used this one in a while. Well, this will be the original Arduino Uno revision 3 that I purchased some years ago, and I was using this to start learning what an Arduino is all about. And I found out with just a little programming and a little bit of knowledge, you know, it can be quite fun. And yeah, see, I remember when programming was a thing to do on DOS. but yeah, I remember the old Commodore 64. But anyway, so I'm kind of familiar with a little bit of programming, basic programming, mind you. So this is where I started out. But for this project here, we're going to be stepping up to an Arduino Mega, which is basically the same thing as an Arduino. It just holds more memory, has obviously more ports I can put in, because by the time I get done, my whole layout is going to be incorporated into one Arduino. And I think it'll be a little bit easier in the long run. I don't know about the programming. That could be a little bit finicky, but they're basically the same thing. They're both microcontrollers that allows you to save, erase multiple programs on a need-to-use basis. Very nice to use. And then for the reverse loop, I'm going to be using a 8-channel relay module that I got off of Amazon. There's other places out there that you can get them from, you know, just do your homework with a little bit of know-how to throw switches, because that's basically what a reverse loop is. You're reversing the polarity, either positive or negative, which is an on or off, via a relay, right or left, on or off. So that's my basis on how I think I can make this happen for a reasonable cost. So $8, and I think I paid $15. Now this is not an authentic Arduino Mega. This is a DF robot, and so far I haven't had any issues. Now, even though they're by two different companies, with it being an open source means anybody can build an Arduino Mega, an Arduino Nano. Yeah, I mean, the sky's the limit when it comes to who wants to build it and why. But there's lots of other companies and people out there that are building them, you know, so take precautions on what you buy, because there's a lot of no-names out there. My recommendation, if you're going to start playing around with Arduino, get an authentic Arduino. And so you know you're not having any problems with the board or any type of issues. You know you have something authentic. Me, I've been playing around with it long enough to where I'm trying something new. But I'm happy with it. Nonetheless, I'm still cheaper than what you would buy a brand name for a reverse loop section automated thingy-mabob. Okay, so many products. So now what I'm going to do here is actually talk about these modules that I have come up with. Regular PCB board, and what this is going to allow to do is make my job a little bit easier as far as hooking it into the Mega. This one here I'm holding in my hand is for the servos. Basically, it's going to have your LED lights where you plug it in, your servo plug-ins, and then your toggle switch plug-ins. And then your row here is just going to be plugged directly into your Arduino Mega, and thus making it a little bit easier, a little bit neater, and a little bit cleaner. And so I'm going to make one for, this is for the servo, so now I'm going to actually make one for the reverse loop. Basically same concept. You put your relay switches in through here, my LED lights, and my 10-pin hookup hooks directly into there, thus make it a little bit easier. So if I have an LED light go out, instead of dismantling the whole thing, I just unplug it from here and put a new LED light. If any troubleshooting going on, I can go to here instead of going through a whole spaghetti bowl of wires. Alrighty, so, okay, now I kind of drew a little schematic on what the PC board is going to look like and what I need to do and where all the pins are going to go to, just to try and give me a basic idea on what where I'm aiming for. So this is my reference here. So alrighty, and we're moving right along here. I've got a few of our jumper already soldered in here and everything. I don't know if you can get a good look at that one. Now I'm about ready to install the pin headers for the micro switches. So what I'm going to do here, see, it's good to have a schematic because I would have lost myself 3 steps ago. Well, got to get my cheaters on here. Alrighty, so we're after 1, 2 spots there. Yeah, hold on there. Okay. Okay, then right there. Here's another one. Oh. Probably should be doing this with a pair of tweezers. May make things a whole lot easier. Yeah.
Right here.
Yeah, a pair of tweezers there. Okay, thanks there, buddy. Alright, make this a little bit easier. A little pair of tweezers there. Okay. Okay, I'm going to my schematic here. I got 4 pins out there. Okay. So we're just going to go ahead and actually get a little bit of tape here, and we're going to tape it down so they don't move too quick. And hopefully it'll stay. So when we flip this over, they don't come out. Yeah, that's not gonna... Yeah, you know what, I'm gonna have to get a little bit bigger of a piece of tape here. That didn't work out so well, everybody. Let's try this again. Right there. Now this would be about the hardest part, is just trying to get these all lined up and seated through the PCB board nice and pretty. So you can put a nice bit of solder on the back of it and make them not go anywhere. And I'm pretty sure there's a lot of people that's got a lot better, easier ideas than me on this one. So let's just try a little bit bigger of a piece of tape here. Just wrap the whole thing here. Try something a little different here. Alright, I think we're on to something. Get her all clipped in so it don't move. A little flux on it here. And what I'm going to do is load myself up on the soldering gun here. Hold it in there and it'll just suck it right on there. You see that? That was quick. You see that, everybody? Okay, well, we're going to do that one again. Alright, we're going to clean our chip a little bit. Get a little bit of solder right there on the end. Hold the next pin in spot. Touch it on there for a second, and it'll just suck it right on in. And that's basically how I'm doing it. I'm just getting all the pin headers set up first, and then I'll go back and I will start in with the actual wiring. Oh, that didn't work out so well, because I don't have any flux on it. So we got it to stick nice and pretty though. So, but yeah, as you can see on the one that I did here, on how I got the wirings all color coded and what have you, and this is what I'm going to do to this one once I get all the header pins all set and everything, and then we'll go from there. Alright, now it's just that simple. Take it off. Check your connections, see if it's all nice and relatively straight. Yeah. I got one that's a little bit crooked there, as you can see. So what I'm going to do is just take my soldering iron there, kind of heat it up, and That's a little closer. We'll leave it there. Don't want to screw up something good here. So yeah, this is our first step in our module. Now I flip it over and start really going to my diagram here and actually wiring this up, and that's where I use the electrical, the voltmeter, and check for ohms, and hopefully it'll work.
Alright, so what I'm doing here is, if you remember the picture I drew, where the loop came back around and wound up back on itself, well, that's going to be a turnout, which is this piece right here. And I'm using this small board just to play around with it and try to design and figure it out here, where we can try multiple things and make it right, and then we have one method to go down on the actual layout and put it in once and for all without having to make a bunch of changes, tack up the foam board and what have you. So we have here is a ground throw, which changes the direction of the turnout. And what I'm attempting to do now is attach this micro switch so that the direction of the turnout controls the power supply being fed to the loop.
I always forget which is the negative and which is the positive on this.
There's a long one and a short one,
Yeah.
right? The short one, I believe, is the negative.
Are you sure?
No, you gotta look it up.
Yeah.
Alright, so we're making some progress here. I have got the hand throw attached to the turnout, so it works. The idea now is to be able to tie in this switch. Contact, no contact. Now it works in theory if I mount it laying sideways like this. But I don't like how that looks sitting on top. How would you disguise that? So my thought was to embed it into the foam. However, once you move around, you get a switch now and then. It's not as reliable. So I've got one here. I kind of glued up a housing for it. Just made it real quick. And the idea is we should be able to mount this a lot more securely and firmly than just this. So I got to figure out my sizing here and get this cut out. We shall see. That was nice and secure, but I missed. Okay. It's a good thing this is the practice board, because while the switch fits in the hole nice and snug and securely now, I kind of missed on the measurement, and it doesn't reach the manual throw. Good thing it's a practice board though, because I'm just going to move the track over. We won't be able to do that on the real layout. Let's try that again. Okay, so what I've done is I built this housing for the switch, give it more security, more solid firm hold, and we'll drop it in the hole here. Well, I also took out the little wheel, I bent the top over so to give it a more secure connection to the hand throw. We'll drop it in. Now, the top, we'll be able to disguise this when we do the scenery around it. Let's give it a shot. Ideally, what should happen now is when we throw this hand throw, it'll push against the switch and we should hear an audible click. And there it is. Success. Now it's up to Roland to get it to work.
Yep. Alright, we're back, and I thought we'd take a quick minute here and show you guys out there what I came up with. If you look at the module, it probably looks a little bit different because this is actually revision 2. So I had a few hiccups there, a few resistors that needed to be put in places that was not on the first one, but we got this one to work, and it works great. So we're going to just explain what I actually did. Go ahead on, Ed.
Alright, so what we have here is we have a power supply, which we scavenged from a computer. I watched a video from one of the channels that I subscribe to, Stephen Bennett Railroad. Very good, very large scale railroad, and very informative. We'll put a link to that video here if anyone else wants to make a great power supply that would provide 3 volts, 5 volts, and 12 volts from one little box.
And actually, I did something a little bit special. I integrated a voltage booster. I forgot what brand it is, but you can actually Google it, and there's several different makes out there. But I was able to take 5 volts and turn it up to 7.5 volts, or I can do 9 volts or anything in between to power the Arduino. So this is the external power source for this via a power booster.
Okay, so now the power supply is going to provide the power to the Arduino module. This goes to the module that Roland created, and you can see some lights here, which is going to give us our indication on our control panel of whether or not the polarity is correct for the route that we want to take. And then here, these are the relays which will change the polarity when it's called for. So let's turn it on and see what happens.
Okay, now, I don't know if you guys heard that little click when it turned on, but via the red lights indicate that these relays are on and these relays are off. Now I used 4 relays because you're going to need 2 relays to change the polarity. You're going to need, well, how did I make this work? Yeah. Boy, I got all goofed up there. Had it all under control here, you know, but no. 2 relays operates 1 loop, okay, which means you would run your A and B line into each relay, and then each relay is going to have that polarity coming out, whether it be an A polarity or a B polarity. And then that's where we, Ed.
Okay, and now how we rig this is these switches are going to be hand throws. We're using the Caboose Industry hand turnout throws. They come in a handy little kit here. And they're pretty much universal. You can hook them up to just about any turnout out there.
Yeah, they come with a little accessory pack there that, you know, Pico, Atlas, different models out there.
So what we have here, this is one of the 2 micro switches. And if you watch the lights, when I push this switch, it's going to switch over. And there we go, and that's what we want. And that's a representation of the polarity changing from positive negative to negative positive.
Yeah, and if you look at the 2 relays here, and actually here it switch, you'll see the lights come on, indicating that it had changed polarities. And then this is via good to go.
Right.
So, but this is what actually very cool that Ed, my God, he put a brain out on this. So, but go ahead, man.
So I didn't like the look of this big old switch, and I took a little bit of tinkering and thinking on how to kind of make this disappear. So what I did is I built a house. I mounted it vertical through the phone, and I built this housing for the switch. And if we come over here, we can see it actually installed on our little test section. So here's our turnout now. If we imagine the rest of the track doing our reverse loop, this is dashed line representation here. It comes back. Right here is where you have the issue, obviously, of the direct short. So what we've done is this is going to correct that, and it's going to change the polarity inside the loop. So right now we have the straight through, and it's one way. And Roland, you want to go ahead and throw the turnout?
Oh, I can't wait for this one. Oh boy, here we go. Here we go. Oh right. Yeah.
Now what you see, the throw bars have switched over to the other side, which will allow the train to come through from the diverging side. And we have a green indicator,
indicating that it's good to go. So we basically took mechanical to electrical, you know, because this is what we needed. I wanted on my prototypical layout was all manual throws, but yet I needed to reverse the polarity and operate a light, which, yeah, there's other companies out there, you know, Digitrack, blah, 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 that can actually do it, but I wanted to give this a shot, and it worked. Programming is still a little bit easy, but I think I still simplified it to a point, and we'll get into that a little bit later, but I still have a couple more modules to make. If you see my other two turnouts here via the servos, I still have to make a module. Well, the first one I made didn't work out because same problem with this one, but we'll talk about that later. but yeah, so I got to make a few more modules, one for a block detector and infrared detectors. So yeah, but dude, I'm so glad this happened, man.
There we go.
There you go. There you go. This worked out very well. So I guess it's time to put it on the track now and at least give it a shot. So when we get back, we'll be at our layout. Alrighty, we're back. I know we were talking about how we were going to go down to the layout and start putting in the reverse modules, but over the last week, I actually made a servo module that we are going to talk about now. I didn't film any of my footage of me making the servo module for our automated turnouts. So actually, if you want to get a close look up of what we've designed here, from last week, this is our reverse loop module that is controlling the relays. And this is what I designed, which is going to control all of the servo motors that we got hooked up to our turnouts. And then Ed actually made a third module that is just a positive negative power strip to clean it up a little bit. And well, did I forget anything, Ed?
I don't believe so. Fire it up.
All right,
see if it turns on.
Alrighty, here we go. Here goes the magic switch. Alrighty. Obviously all the lights turn on. You heard the motor spool up and everything. So, you want the honors?
Absolutely. So
let's go do this.
Here, you'll notice, and we're just going to concentrate on these two lights here. So
Okay.
at some point, these will be routed to the control panel. And we can give you a sneak peek of that here in just a moment. But we're going to be dealing with the turnouts. And so this light right now is showing red. And when we activate the switch to control the turnout, you'll see that it switches colors, and that's so on our control panel we'll be able to tell what route, either the straight through or the diverging route. But if you also notice, the turnouts themselves are both controlled.
Look at that. Look at that. And it's a nice simple program. Once I'm dealing with Arduino, I got the one separate program for the reverse loop and then one separate program for the servos. Now what I have to do is do the Arduino is to combine the two, make one long sketch so it can be read as one. And then for my IR sensors, which is going to be routed in, that's another program that's going to have to be routed into the main program, the main program. Yeah, a lot of programming. But I kept it simple. And if there's any comments or anything when we get to that point, please give me a shout out, because I am nowhere near a professional or an IT. So I guess the next step is, Ed?
Well, you want to show them the control panel first?
We got the control panel. Yeah, I was working on this last week too, or this past week, or actually yesterday as a matter of fact. And this is what it's going to look like. So, and if we put the Digitrack there, these are going to be the toggle switches for the spurs that are just going to be turned on and off. These are going to be the turnouts. So the LED lights that you see here, red and blue, are actually going to be changed to a green and green. And then this side here is actually going to be going straight to the track power. And then I got the reverse loop LED lights here and the reverse section LED lights. So yeah, I think we did a good job on this one.
Is it going to stay like this?
I'm actually going to paint this. Actually, Ed was talking about a pretty good idea, because I'm going, dude, how are we going to make the nice little lines in here look pretty? Well, he was going about first painted white, or your base color, your silver, whatever you want your lines to be. You paint that first. Then you take pinstriping tape, you know, like you would on a car, or I think they even have it for models and stuff. But, and then you tape it out, and then you spray it with black or your top coat, peel off the tape, and then you got your lines. So that's what I'm going to do. You know, when it comes to the board like this, everybody's going to have their own way of running the toggle switches, your LEDs, on how you want to run stuff. This is our version of this. Your layout's going to be way different. So I guess now and this is what the back looks like. So kind of give you an idea. This is still the beginning. We still got a lot more resistors to put on. Yeah, and a lot of wires. There's just a lot of wires.
That's right.
Yeah, just a lot of wires.
So for now, I guess we'll see you downstairs on the layout.
Yes, we are going to the layout now, and we're going to actually see if this thing actually works. Until then.
Roland, what's going on here? We got a big mess.
Yeah, looks like a big old spaghetti bowl down in here. Like I said, a couple more things that we're hooking up. So yeah, and it's coming right along.
Well, I can see we got some serious cleanup to do. Yeah, as you can see, there is a big mess. We've got all of our stuff kind of scattered all around, and that's just part of the process. And, but it is a mess. Anyways, all right. When we come back, we'll be installing the last module.
Alrighty, that wire's hooked up. So yes, when we come back, we're getting real close to this, everybody. So let me clean up here, and we'll be right back. Alright, well, we're back. And I thought I'd give Ed the honors of installing the last module that I have built for the Arduino for the infrared detector. So yeah, he's just doing the last little bit of touches on it right now. He's got to make the little feeder jumpers that goes over to the Arduino Mega. And once he gets done over there, then we'll walk in and I'll show you what we did. How you doing there, Ed?
We got it mounted.
Alrighty. Oh, that looks good. That looks good. Okay.
So now we just got to size up. This is our piece mounted to the panel. Now we've got to size up our wiring here. I think we can go something like that.
What do you need? There you go. There you go. Now we're using just regular DuPont connectors like you'd find on the end of a servo. Yeah, it's a nice little kit that I bought. It comes with a whole handful of the DuPont connectors and the male and female ends to connect them with. And then you're going to need a special tool to make this happen. You really just can't use a pair of pliers. It just doesn't work. And yeah, I tried. It just don't work. So I broke down and I got a decent pair. Then I also got the JST connectors, I believe. Comment if I'm wrong. But anyway, we got those to work on some of the other connectors to kind of segregate one spot to the other.
Now.
Yeah. You need your singing specs on that one, man? Because I need mine. Nah, it's funny. About a mile away I could see this, but right here, nah, I don't see it. Right at the age of 40, eyesight went. Alright, so there you go. Yeah, exactly. Look at him, look at him, look at him. Can't believe we're in the home stretch with this. It's amazing. I have racked my brain for weeks getting all this spaghetti bowl together and everything, and there's no really color coding to anything, and yeah, a big old mess underneath there. But right now it works, and we'll clean it up a little later, cut wires and everything, clean it up, you know, what have you.
Well, we're actually going to redesign the control panel itself because we've made some changes. Now we have holes in places that don't need holes.
Yeah. A toggle switch that I installed, just to come to find out, didn't need it. Yeah. So we're gonna call this a prototype. So, how you coming there, Ed?
We got one done.
All right, we'll tell you
I
what.
just need to install this now. Is it going to matter what side the stripe wire is on?
No.
Doesn't matter.
No, it don't matter.
Alright, well then we will go ahead and get the ends put in. Alright, they are set. That's one done.
Alrighty. Yeah, then after this, what do you think? Maybe get one of my trains and start going through it and seeing if there's any kinks or hiccups.
Yep, that'll be the next step, is to go through and proof the track. We're probably going to find spots where it doesn't go through nice and smooth, and it's all part of the process. We'll get through that and make little tweaks here and there.
Yeah, cleaning the track here and there. Wow, dude, you know we're on our way to the topography next.
That will be the next
Oh
step.
my God, mountains, dude, mountains.
Mountains and rivers and dirt and grass and trees.
Oh my.
Oh my. And buildings.
Oh, holy cow. Oh, that's a whole nother episode there, man.
Yeah, it is.
Sweet.
Okay, these are made.
Alrighty. You sure you don't need your glasses for that, man?
Oh, it's already hooked up.
Alrighty. And then the red and black positive and negative just get hooked directly to your board that you have made.
My jumper?
Yep.
All right.
Okay. Now, when I ran the wires for the sensors and the LEDs already, the two that are right on top there, yep, right there, those got the JST connectors on them, so they can only fit in one spot. And I'd say, yeah, aim for the first two there.
Need smaller fingers.
Yeah. Yeah.
All right, we got those.
Okay, then
So now we need the
underneath-
sensors,
Yep,
correct?
underneath on the left, you see the braided wire there.
Yep, I've got them.
Okay, I'd say just feed those up and through and plug those into the first two sensors that those go into. See, you're learning Arduino already. Look at you.
That's right. Pretty interesting.
Yeah, I kind of specifically designed these modules that he's hooking up to make it a little bit easier for almost like a plug and play. And I don't know if you would call these like breakout boards or modules. I wouldn't know the proper name for what I just got done building. But it's just like a jumper between the sensor and the Arduino Mega. And I think it looks very nice, very well organized. And yeah.
So did you have opportunity to explain why we have a laptop down here?
Yes, at this point, I'm going to have to download the final program that incorporates the infrared sensors into the overall program. Because I started off with the reverse loop, which is the row of relays on the left, and then I built the servos and all the sensors and lights and the micro sensors for those, and then I built the infrareds. You know, so yeah, there's a lot going on in there. And this is where the computer comes in now, because then I got to programming it. And I actually have the lower track here as a programming track for the Digitrack. So yeah, I got it all hooked up, and I think that's where the computer is going to sit. I think it's out of the way, and of course I got a nice little boom box down there, a nice little subwoofer going on. So yeah,
Okay.
that's where that's going to sit.
They are hooked up.
Oh my God, we're done. That's the last little bit. All right, everybody. Holy cow, electrical. All righty, so I guess this is the final. Oh yeah. You gotta hook that up. Okay, beep, beep, beep. Alrighty. Alrighty. We are all done. Well, Ed, I believe that ends.
We're not all done.
Well,
We're all
no.
done with the electric. We haven't done one thing though.
What's that? What's that?
We haven't run a train.
Well, wait a minute. We haven't even showed the crowd yet what we even done with the board over here. You know, we haven't even fired it up and let them show them the pretty little lights.
Well, let's get her fired up.
Okay. As you see, we got 2 trains set up there. Well, now it's time to see if this has all been worthwhile. Man, I can't believe we're at this point. I actually got the electrical done and everything. Now it's time to turn it on. Follow me. As you can see, we got our Digitrack here all set up. Let's make sure everything underneath here is all set up and good to go. As you can see, my little spaghetti bowl here worth of wires, and yeah, and I can't believe it actually works. So let's go ahead and plug in the Digitrack. Alrighty, let it spool up. Okay, let's reach down underneath here. Let's turn in our other power supply on for the Arduino. Alright, let's lift this back up a little bit. Make sure all of our lights are on our 4 modules that we built. Our LEDs are working. Our Arduino Mega is all turned on. Okay, let's turn the track power on. We're not getting a beep, 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 beep. That means that there's not a short. That's a good thing. Oh, what train you want to run, Ed?
Let's start with this guy right here.
Okay, we'll start with the 060 here. Okay, now that locomotive doesn't have sound. You sure you want to run this one, man? It ain't got sound. Uh-oh, uh-oh. Oh, you guys got to get a look at this. Here, come on in here. Take a look at that. I can't believe that actually works. Nice. Now this is all done through the Arduino. Uh-oh, uh-oh, we got a train moving. We got a train moving. The reverse loop worked because that was a crucial spot. Alright, let's give it a little juice. Alright, there we go. Coming around. Coming around towards you, Ed. I'm going to flip it here around here so it goes through the town of
Sarsaparilla.
Oh, you know what? I wonder if we're going to have a problem going through that tunnel coming in this direction. You want to keep an eye on that tunnel? I'm going to slow it down a little bit. Yeah, that tunnel's been giving us a little problems there. All good? Nope. So we all dialed in with the 4335. Alright, let's give it a little power. Let's see where we're at. Now this one here doesn't have sound, it just has movement. So it's going to get be a little quiet here. Alright, so are we thrown in the right proper direction here? Okay. Let's give it a little juice here. Uh-oh, uh-oh, uh-oh. I think we, it decoupled itself. Alright, no worries. We don't, oh, those are all the plastic ones. Yeah, I gotta get Katie metal couplers on there. I got some plastic ones that are hooked up to metal ones and they don't seem to like each other. No worries. Alright, let's give it some juice some more. Coming around. Dude, we got a train running. Wow.
Let's see if she'll make it all the way around.
Alright, let's do it, let's do it. You can see our tree grows in sarsaparilla. Our one lonely tree in sarsaparilla so far. Got our reverse loop in the correct spot here. Okay, very nice. I think that track maybe needs to be cleaned up a little bit there.
Yeah, that's what we'll be doing for the next...
Coming through the 3-way, we're all switched off all nice and neat. No derailments yet. Okay. Dude, she's coming around for her first loop. Alright, let's see if she can do another loop here. Nice! Alright, now let's see if you can go through our little reverse loop here without decoupling itself here. Nice, look at that, look at that, look at that. Yeah, she's running herself now, man. Wow, Ed, I am so excited.
That's right, we're running our first train.
From a CAD program till a full-blown layout. Well, heck, I'm ready to try to see if the other one wants to run now. It's getting a little lonely over here. We gotta see if our infrared detectors work and work properly. Why don't you have... Oh, I'm sorry. We don't play. We operate around here.
That's right.
We operate.
Well, where's your handheld?
The handheld's over here. It should be already dialed in. 539er. Okay.
Okay. So,
well, Ed's going to attempt to operate 2 trains here. Alrighty. So he's got to time this accordingly. Alright. He turned the power track on for the tunnel track. Okay. The tracks are flipped. He's giving it the power. Oh, oh, oh. Why do we... That shouldn't have shorted. That was weird. That shouldn't have shorted.
well, that's part of the process though.
Alright.
So, what we have to do now is we have to go around and find all the little quirky spots.
Yeah, see, like
get them taken care of.
Yeah. I guess this is where troubleshooting comes in at.
That's all part of it. So, we have 2 trains running right now. Look at that. Yeah, that's that crossover there.
Yeah, maybe
We may have to add some pickups to it. We're running 2 trains.
Nice! Nice! Oh, we seem to have lost some trains.
Now, the funny thing is we've been running these all day and we haven't had a problem. All day. Yeah, all day.
You lost a train, bro! Boy, you're gonna have some upset loggers. There you go. Looks like you're connected.
Oh,
Oh, really?
it's a dead spot there.
Yeah.
I think it's your locomotive.
There you go. Yeah, I think it might be the locomotive. We didn't clean this one, did we yet?
No.
Yeah, this one may need a little cleaning. Maybe a little bit more oil in it, but she's running, man. Take a picture. It says, hey, want to keep going. Stopping for paparazzi here. No. Yep, you just...
Yep, I flipped it in there. Yep. All right.
No.
Oh, I lost you.
Why? Alrighty, we are there. Well, I hope you like the couple trains going around, and so where do we go from here, man?
Well, as you saw, we have a few glitches.
Yes.
And that's totally normal. Now that we got them operating, we're going to take a few days of just running around with the engine, and we're going to find all the little trouble areas and tend to them. Some of them may need a little bit of filing, a little tweaking, a little adjustment of how the solder joints are. And then something else we're going to do while we're doing that. Is if you remember when we started laying track, we had to take some of the track ties off. And I said we're gonna hang on to them. Well, here's the reason why. In our connections here, we have a big gap in the ties, and when we go ahead and ballast it, it's gonna look pretty weird. So we're gonna open up our little box of the ties that we saved, and we're gonna bring it right down in here. Is a good spot. So I've taken the tie and I've kind of trimmed off in the top a little bit so that it's nice and smooth. And we'll just insert them underneath the rail. And there you go. Now you'll never see the gap, you'll never notice it, and once the ballast is laid, it'll look really nice. Another one up here.
There you go. Very nice. I believe this is it for Holy Cow Electrical, because by golly, Holy Cow Electrical.
Yeah.
So yeah,
the next step is topography.
Yeah, start getting some mountains going on here. We can't forget the troubleshooting.
Troubleshooting. Let's hope we can just skip that and go right to the fun stuff.
You know, well we can. We can.
No. You're right. We're gonna spend a little bit of time troubleshooting, making sure all the track is working, and we'll go through your engines and your cars. You got a bad coupler on that train that keeps separating.
Doing it. Sweet. Aww. Aww. Yeah, it just died. Ah. You sit here, you little shit. I can't fall off the track. Oh, that's because. Oh.
No, you didn't throw the switch.
Alright, well, tell you what. I don't know about this, man. Taste it. Yeah, I think it was a wise decision. I want to thank everybody for on YouTube that's given me the idea for this whole reverse loop and mixing Arduino with DCC. Because, yeah, you guys gave me a good idea on how to approach this. So if you guys are kind of curious about what my program is and what it looks like to make the reverse loop, the servo, and the infrared sensors all work as one. And so far, it seems to not have a problem, and it seems to work. So if you're interested... Alrighty, everyone. I'm going to show you the Arduino program I created using the Arduino Mega. Now, if you're not familiar with Arduino, it is an open source platform used to create personal programs for your projects. And if you would like to have more information or get more information on Arduino, I would suggest going to their website at arduino.cc. So, the program I created is a very simple code used to operate the different sections on the layout. And right now I'm just going to quickly go through it and kind of show you what I came up with. So the first section here is the Servo Library, which basically is a little bit more information to tell the servo which way to move and how to move. So, and then we got some constants and some integers here, which basically tell the toggle switches, the LEDs, which pins are going to be attached to on the Mega. The position here basically tells the servo which position, which degree to start the servo out at. Going down to the reverse loop part of the program here, the micro switches here are attached to these pins, the LEDs are attached to these pins and so forth, the relays to these pins. The micro state indicates which state the micro switch starts off in, which this one here, I'm telling it to start off in a low position. The IR sensor part of the program here, I got two sensors that are attached to these pins, and the two LEDs are attached to these pins. The IR state, once more, I set it to high for the initial part of it. For the void setup here, this is where I told the program to attach the servos to which pins to these numbers. The toggle switches that I assigned to the pins are basically telling it if it's an input or an output. Here, the toggles are an input, the LEDs here are an output. The reverse part of the program, once more, the micro switches are inputs, LEDs and relays are outputs, basically read and write. IR sensor, once more, they're input, LEDs are outputs. Very simple. For the void loop part of this now, this is where the program gets a little interesting. I basically use just if-else commands. If the toggle state is equal to high, then it's going to tell the servo to move to 50 degrees and turn on or off the appropriate LED light. And if it's not equal to high or equal to low, then it's going to write the servo to the 90-degree angle and turn on or off the appropriate LED light. And so forth with the toggle 2, and yeah, that's basically it. And for the rest of the program, for the reverse loop, it's going to read the micro switch. If it's equal to low, it's going to turn on or off the appropriate LED light and turn on or off the appropriate relay, switching the polarity on the main rail, hence reverse loop. For the second micro switch, because I got two reverse loops on the layout, if the micro state is equal to low, turn on or off the appropriate LED light, turn on or off the appropriate relay, hence reversing the polarity. For the IR sensor part of the program here, even simpler. If the IR state is equal to 1, it's going to turn an LED on. If it's not, it's going to turn it off. Yeah, and that's basically the whole program. Very simple, straightforward, and to the point. If you guys got any questions or comments, please let me know. Please throw it down in that comment and we will respond to it. If you've come up with something like this with a different program, I would be more than interested to find out how you came up with it. So, yeah, I hope you enjoyed it and stay tuned for it. Yeah, so
That's it.
That's it, bro.
That's it.
Holy cow, electrical. Because Boy, it turned out to be a lot. More than what I anticipated, but I had fun doing it. So, until next time, don't forget to subscribe. Hit that like button, hit that bell, that ding ding. Don't forget to support your local hobby shops. And this is Ed, I'm Roland. Once again, this is Two Dudes in a Train. Have a good one.